Hello, everyone. Today, we're going to talk a little bit about sustainability and its impact on security. Here, we were going to be a panel, but unfortunately, some of our panelists had to leave earlier, so it's going to be an amazing fire chat. Can our panelist give us a bit of background of who he is and why you know so much about security and quantum?
Oh my God. All right. Thanks, everyone. Good afternoon. It's a tough task to fill in for 3 people, right? So one good thing we can do is if you have any questions, you can raise your hand. So it will help moderator as well, right? So that way we can keep it very interactive. I am Dr. Satyam Priyadarshy. I am the Chief Data Scientist and Technology Fellow at Halliburton. Halliburton is one of the top energy services company, and I run what is called the Center of Excellence for Big Data, Data Science, and Digital, towards what is called digital transformation of energy industry. One of the most challenging part of energy industry is how do we make ourselves ready for the future. And besides that, I am a professor at a couple of universities in India and US, where I teach artificial intelligence, digital strategy, and I train executives around the world on digital transformation. Because if we talk about energy security, digital will play a critical role in it. And my background is I have a PhD in quantum mechanics applied to biophysics, and I'm a pretty well-known scientist in the field of nanotechnology as well. So I have a diverse background in technology, science, and business. I've turned around some companies. I'm involved with a couple of startups as well. So, but all of that has to do with data. So foundation lies in the data, domain doesn't matter. So we can talk about that more in details.
I wanted to start with the easiest question to ask and maybe the most loaded to answer. What is sustainability to you?
That's a great question. Let me ask first the audience, how many of you know what sustainability is?
Show of hands, come on.
Do you know what sustainability is? Anybody? See, it's a very nice term to use, right? Whether it's sustainability related to environment, whether it's sustainability related to energy, food, whatever it is. But one of the most missing component of sustainability is that human beings have to reduce consumption of resources. We focus on sustainability in terms of usage of resources. In how do I make it optimized, how do I get more resources, but actually to be sustainable, one has to learn how to reduce the consumption, which is, I was just walking around the whole complex today. Everybody is talking about smart city, smart building, smart device. Nobody's talking about smart human beings. So how do we get sustainability then? Right? So sustainability is about how do we survive, and especially, I think yesterday or day before yesterday, there was news that we have become 8 billion on Earth, correct? And that means the resources are limited. 2 days ago, one of our friends was presenting a nice infrastructure, how to go and live on Moon or Mars, right? They were showing these houses of the future. I think that's maybe small percentage of people will go there, but most of us still have to live on Earth. And then, if you have to live on Earth, how do we make the limited resources that we have, that we can actually live on it? And that's the key part for sustainability, that how do we use the resources wisely, which are limited in value, in quantity, and we can't just evolve everything, right? Whether, if you look at nowadays the trend to make material from animals or material, fake animal meat. Now, all those things are coming from the same resource pool. Resource pool is not coming from Mars or Moon. So how do we actually make use of those resources effectively so we can all 8 billion and maybe a couple of years we might be 10 billion. How do we actually do that? So sustainability is, I think the key component is how do we reduce our consumption of resources that we have on a on on a regular basis.
I wanted to ask you, I know research papers are a touchy subject, but there was this very cited 2019 Cornell University paper saying that quantum was the future of sustainability for us because, for instance, now that we all rely so much on data analytics, for training a natural language processing deep algorithm, it took 626,000 pounds of carbon to get to the result. But with quantum, you can do that at a fraction of the energy. So can you tell us if that's really a more sustainable resource, quantum computing?
Yeah, so currently if you look at the quantum computer, so when we talk about quantum, there are a couple of things. One is the hardware side of it, that the quantum computers, right? The other one is the algorithmic side, which is the computing part, correct? So we have to understand what areas of this we are talking about. So currently, in order to have a quantum computer which can actually do processing, even equivalent of HPC, what current HPC or high performance computing is, that requires quite a bit of energy because you have to keep all that hardware very cold, correct? And hence, if you look at today's term, a quantum computer which matches a high performance computer today would require a lot more energy than traditional HPC. So is it really a great business value? We don't know that, right? Because how much energy can we produce to do that? On the other hand, if you look at quantum computing, which is done on traditional systems, so people can call it quantum simulator or things like that, that does not require the same amount of energy as a real quantum computer. But in order to get maximum benefit, we have to have quantum computers so we can do the quantum computing on them. So that will require few more years of maturity in terms of reducing their energy consumption. Now, coming to the question whether we can do NLP and whether we can analyze the data faster, my challenge with that is, do we really need to analyze everything faster? Right? We have to look in the context that we are in. Context is a critical component of any business value, right? Whether it is academics, whether it is science and engineering, or whether it's a pure business. What value are we talking about? In order to find that value, what is the right amount of computing needed? One has to do that. Not everybody needs to go and do deep learning, for example, right? It has become a fashion, right? You can write a paper, deep learning for this, deep learning for that, but in terms of business, it doesn't improve much. So one has to look at the incremental value that brings with the resources that are there. Hope I answered your question.
Yeah. I was thinking, does quantum improve security or not? We actually had a conversation and you had very interesting thoughts about energy security. So I would love for you to share your thoughts with the audience.
Yeah, so the most important security as relates, anyway, we talked about population. So energy security is the foundation of every security that we talk about. Because without energy, we can't do anything, whether it is existential security for us, whether it is food security, whether it's environmental security, it all depends on energy security. And energy security is the hardest of all because the foundation of energy is that we want to produce energy at the lowest cost possible, but it has to be resilient and sustainable going forward. Even at today's consumption level, we are talking about energy transition. A lot of people talk about that term. I'll come to that in a second. Can we actually really figure out a way to produce that energy that is needed today at the lowest cost possible? And in order to do that, one has to really understand what are the different sources of energy that we have, what are the different sources of, what are the different methods of consumption that are there, how does that ecosystem come together? So if we can actually figure out that portion of it, then we can actually do what is called really do energy security for ourselves. And this energy security concept, it will be different for different countries, different organizations, what is energy security for your house, your building, your country will be very different because we don't live in exactly the same place. Environment plays a big role, and hence energy security plays literally in conjunction with environmental security, which plays directly with food security. And hence, if we can actually figure out energy security, we can figure out most of the other securities.
That's an interesting thought. Certainly something we've been trying to answer with this expo overall.
Absolutely.
How to achieve this.
Absolutely.
I mean, I think it's clear how security and sustainability have many touch points. I would love if you could share with us how your organization is contributing to this through quantum, especially, and if you could give us an example so it's easier to understand in practice, that would be great.
Yeah, so application of quantum computing in energy sector is very limited right now, of course, because the challenges are very complex. So all of us are trying to figure out how can we take advantage of it and where, right? Whether it is solar, for example, or whether it is, I'm talking about industry more specifically, or whether it's geothermal, whether it's hydrogen, carbon capture. All of these areas are open where we can actually learn from simulations how to do best. And as a result, some places we can do simulations which are faster and in a timely fashion. Somewhere we can actually build, say, for example, new materials that can be used. And those are what I call algorithmic materials that can be actually more powerful. If we actually bring those things together, then if you look at energy industry, we have a lot of applications. But applications currently with the available quantum computers, that's not really business. What I say, it does not bring the same business value, or what you call a return on investment is not there. But it is a good R&D project, right? But at the same time, if you don't do it now, then if you wait for 10 years, then you have lost a lot of learnings. So hence, sometimes you have to do what is called R&D, and R&D is not always directly a return on investment immediately. So it is called return on innovation. And I think return on innovation is significant for going forward with quantum. And I think that's where energy industry will benefit.
Yeah, I agree. Setting the right foundations now will reduce problems later for sure.
And even last couple of days, I think we have been discussing on this stage, talent is a requirement. I think a lot of different panels, because quantum talent is needed, right? Very few universities are into that business yet. Especially, of course, quantum mechanics was born out of Europe, right? And since I've done my PhD in it, I know a little bit more about it. But at the same time, these same scientists have not been trained into the commercial side. We can all write very nice scientific and research papers, but to apply that and coming in collaboration with the industry is required, and that requires a different kind of training. And I think that's where these things can progress faster.
What would be for you the biggest challenge that we face right now when ensuring normalization of quantum, but from a sustainable point of view?
Tough question. I think one is this ecosystem has to evolve, right? A lot of people have been doing little things in many places. So learnings from that, especially there are 3 or 4 companies which are into building the quantum computer, right? And the knowledge, very few people understand exactly what's happening. So that knowledge has to be spread out in an ecosystem where people can take advantage of it. Second is very specific use cases that can actually help people to learn how it can be applied to practical problems of today, right? For example, everybody, if you talk to most people in quantum world, they will say that they are doing optimization problem. Now, optimization with respect to what? Correct? How much is of value that is, right? And large portion of it is done in financial sectors, right? Optimization problems. But those problems exist in energy sector as well. they exist in manufacturing, right? If you look at, let's take an example for solar panels, right? Recently, India and some Middle East countries have actually deployed industrial scale solar farms. Now, we all know the efficiency of those solar farms is converting solar energy to electrical energy is about 15 to 25% only. Correct? Now, but all these places, whether anywhere in the world for that matter, has environmental impact. Now, for example, I'm sure in Middle East you will hear there are sandstorms. In India, we have other different kind of dust storms, right? Now, if those things are coated over it, that efficiency reduces significantly. Now, how do I optimize for it? So that means I need to really look at the weather data, I have to look at the storm data, I have to look at thunderstorms, and then build systems which are robotic systems which can go and clean those solar farms, all right, so that maximum energy can be converted. Otherwise, your efficiency of such a large-scale solar farm has reduced to nothing. And if you have 3 or 4 coatings of sand on them, you will have zero efficiency, right? So these kind of problems, when you have to mix data from multiple sources, especially we all know weather data is not small size, to analyze it, forecast it, and then make decision on it, these things require compute of the next generation.
What would be your advice for the next generation entering now this space?
Wow. My advice is learn from different domains. Don't be stuck in your own domain, right? I challenge universities for that. You know, university professors, and there may be some here, and I'm also a university professor, so I can say it with full responsibility. We always talked about collaboration in universities, but those collaborations were always between 2 chemists, 2 physicists of the same field. That's not really collaboration. Collaboration today requires collaboration between a biologist, a computer scientist, a business person, right? Then you have actually something more meaningful. So universities have to learn to create people with diverse, what you call education, experience, so that they can actually solve real-world problems, right? That will be a true collaboration. So if university is not teaching, go and learn yourself, and be more useful, because just learning chemistry will take you only so far. But learning about business, learning about the practical applications, how an engineering firm is doing, is actually more valuable. So that would be, I would call it, true collaboration.
Big words of advice, given how everyone is turning to specialization. This cooperation is very, very needed, of course. Yeah.
I don't know. My practical is different. I'm a trained quantum physicist, turned into a technologist, into a business person, and I only can see that I can go to any industry, and I've worked or consulted in almost all verticals now. That's all because of diverse backgrounds. Otherwise, it would not have been possible. Otherwise, I would have been a very narrow scientist for life, which would have been good, but I think you would not get the wide exposure. So I think for young generations, and since I teach my courses in India and US, I tell all my students that data science is a great course, but apply it to some domain. Don't go and do only social media analysis. Go find education, go find agriculture problem, go find a manufacturing problem, transportation problem, and solve that. Then your degree has more meaning, because it is actual practical application. Go to a marketing professor saying, what can I do it for you? Don't ask a data science professor, but go to a marketing professor, right? So you get this diverse experience that becomes very important.
Maybe before we close this fire chat, and maybe turning back to this core topic of sustainability, I would like to ask you, in your experience, is sustainability a big focus in quantum computing development, or is it something that we should improve regarding future development of the industry?
No, I think what I say, one is quantum computers, next generation. Some of you may have heard the term biocomputing or DNA computers, right? So eventually, we will have computers which are more efficient and much faster based on resources that are more manageable. Today we don't have that, but I think in next 5 years, 10 years, we would see good progress in that area. And that would result, I think, for the betterment of humanity, actually to keep our sustainability score a little better.
Well, thank you so much
Thanks so
for
much.
holding your ground so well.
Thank you so much.
And thank you so much, dear audience, for staying with us so late today. Have a good day.
Thank you.